Hey, what's up YouTube? Welcome to another video. Today we're going to be talking about mutexes. So what are mutexes? Mutexes are ways of isolating processes in order to mutate uh, a single variable. So for example, let's say that in this example I'm going to be showing an account balance. We're going to be trying to mutate that account balance concurrently. Well, no, actually not concurrently. We're actually going to be doing this concurrently, but you need to lock that mutation in order for the variable to change properly. Meaning, we're going to have to make sure that only one process at a time is mutating this specific variable, and that is something that will be done by doing mutual exclusive processes. And that's why this is called a mutex, or a mutual exclusive process. Probably you've heard this as semaphores before, or a semaphore. A semaphore is when you have multiple threads trying to access a specific variable, but you only want to allow one thread at a time. Once that thread is done doing its task, then another thread can keep on going doing its process. Another thread can keep on going mutating the variable, carry on its process. So that is what a mutex is. It's a locking mechanism that allows threads to mutually exclusive mutate a specific variable. So that is what we're going to be seeing today, and hopefully with this you can grasp more on how to use this locking mechanism in order to avoid race conditions. And by race conditions, I'm referring to, for example, not doing this properly and therefore not mutating the variable accordingly. And hence, let's say if this would be a bank account, or actually a bank account, probably the transactions are a little bit more delayed probably, or there's like an event queue, whatever. But let's say that we're trying to do this at a very fast pace. Let's say that there's a trading platform, so to speak, just to have an example, and this specific platform is doing transactions live, so you would want to do this with mutual exclusive mechanisms. So let's go ahead and let's start with the example. So what I'm going to do is the following. I'm going to go ahead and I'm going to declare a couple of variables. Actually, first I'm going to declare a struct, transaction struct, and this will have a type transaction. So what is the type of the transaction? And that's kind of like the description. Probably the description is more fitting. Description. And then I'm going to put amount of type integer. Then here, once we have that, I'm going to create, first of all, well, let's go step by step. First, I'm going to create a global variable called balance. This is the one variable that we are going to be accessing throughout the example. We're going to have deposits. So the deposits it's going to be a slice of transactions where each transaction is going to have its description. So what type of transaction is this? This is a type of deposit, and this is going to be having a value amount of 500. And I'm going to do the same but for 200. And I'm going to create another one called withdrawals. So withdrawal, same thing, transaction. And essentially I'm going to copy this, but instead of deposits, there you go. Instead of the deposit, it's going to be withdrawal. There you go. So there you go. You have an example there on how you can change stuff in BIM really quick. Anyway, by the way, so just so you guys can follow along, I created the mutex file here, which has the package concurrency, and I'm calling the concurrency.mutex main in my main function. So all the logic or all the manipulation or all the example is going to run inside here. So just so you guys can see, test, make sure that I import properly the FMT. Okay, and I'm gonna run this. Perfect. Which, by the way, my execution method is the same as go run. Do I have a main package? Oh, command main.go. Okay, so go run command main.go. So the same thing. In case that you don't know what I have in my execution file, yeah. So there you go. Just so you guys are aware of how this is running and you're not second guessing. So let's go ahead and let's start with the example. So obviously we want to make use of concurrency and multi-threading. So what we're going to do is create our Go routines. So I'm going to go ahead and create 2 Go routines, one for withdrawals, well, one for deposit and one for withdrawals into this bank account. Actually, before I keep on going, I need to create the functions deposit, which is going to have a value parameter, and that is going to access the balance variable, and it's only going to increment it by the amount that we pass as a parameter, as an argument. And then we're going to have the withdrawal function, which is going to be doing the same, but it's going to decrement the global this variable right here, right? Anyway, so let's go back to the Go routine. And I'm going to deposit. Well, actually, let me do the following. Let's run a for loop and let's do the following. So I'm going to say the following: for each transaction within the deposits, run a Go routine. Let's clean this a little bit. All right, there you go. Run a Go routine and pass that value or pass the transaction. Actually, this should go here. Okay, let's go step by step. So again, this is an anonymous function where I should just put actually, let me see if I can simplify this. I can probably just do this, go, and then I'm just gonna pass the transaction.amount. Yep. Let's do that. And I'm gonna do the same, but for the withdrawals slice. So withdrawals. So go withdrawal. And I'm going to pass a transaction.amount. Expected but found. Oh yeah, I'm missing the, there you go, from the mutex main. Okay. Alright, so if we make the math and we add this up, so if I deposit 500 and then 200 and then I withdraw 500 and then 200, we should have a zero sum effect, meaning once we print the balance here, we should see a 0, right? Because we're withdrawing and depositing by exactly 0. Jesus. We're depositing and withdrawing the same amount. There you go. All right, so I'm gonna go ahead and I'm gonna run this again. And well, I have to get out of the test printing, but everything looks fine. We do get the balance 0, which is what we expect. But oh, what's going on there? We see 700. Now we see 0. Now we see 500. Now 0. Now 0. And sometimes you may see some irregularities, as you can see. And that is because we are looking at race conditions, meaning that some threads are not taken into account sometimes because one thread arrives at the same time, so another one is ignored, and that is exactly what we're trying to avoid. I'm gonna make this even more evident. I actually want to print every time there's a single withdrawal or deposit. So actually, to make this faster, I'm gonna copy paste this from my notes. Okay, so that's one. And all right. All right, so this is just you know, a visual aid for us to see what went there. And there's nothing wrong with my, well, it's not that there's nothing wrong, but it's very telling that you cannot even see the print function because the functions are not allowed to run properly. You cannot even see the print statement, and we should be able to see the print statement. So what can we do about that? Well, we've seen weight groups before, so we can go ahead and create weight groups in order to wait for those processes to run properly with the run properly and see the print statement. We're not yet seeing the locking mechanism. I want to go step by step and seeing why the locking mechanisms are important, but first let's add the weight groups. So actually, let's maximize this, and I'm gonna create my weight group here. So sync.weight group, there you go. Weight group declared, redeclared. Where did I do redeclared? Oh, probably I have another weight group in that concurrency. Yeah, in the weight groups, of course. I'm gonna call this weight group 2, just so that there are no like clashing variables. Okay. Anyway, so I'm gonna go back to the for loops where I have my concurrencies, my go routine. Sorry. So weight group 2 dot add. I'm gonna put 1. Then there's two things that I can do here. I can either pass the weight group as a variable. I don't know how messy this will be. I'm trying to make this as neat as possible. We can also create an anonymous function and make it a go routine, and then pass the deposit here. And then within here, we're gonna do the following. We're gonna pass a amount of type int. This would be amount, and then this would be the transaction.amount. So we're doing the exact same thing, but why am I doing this? Because then now I can easily do the fair and then do weight group done. I can get rid of that now. Or we can add the weight group parameter. But the thing is that with the locks, this will become more and more cumbersome, which I don't want to clutter the function, not for this example at least. So I have my weight group there, and this is where my first for loop ends. So I'm gonna do the same thing to my withdrawal process. So I'm gonna do go func, invoke it, pass the withdrawal inside here, And then in my anonymous function, I'm going to declare the same thing. Amount of type int, and then here it would be the transaction amount. And now here I can get rid of this and I can just pass amount. Same thing, I need to add a counter for that wait group to run successfully. Defer wait group to done. And actually this one should be referring to the wait group too. And that should be it. And then lastly, we're gonna add a wait clause. Okay. So if you want to know about mutexes, you could say like, okay, this is probably the only thing that we need to do. And now you can actually see the print statements and you can see the balance, and the balance is 0. And I'm gonna run this a couple of times. Again, you will always have a different sequence of go routines, but you always see the 0. And you may say like, hey, are you sure we need logs? This seems to be working fine. And you can see the print statement, so why do we need the logs? Okay, so let's go ahead and let's go one step further. What I'm going to do is create another for loop. And actually, to make this easier, I'm going to create a for loop here, and I'm going to say the following. For I is equal to 0, as long as I is less than 50, I plus plus. And then just put the deposit here, the deposit function here. I'm gonna do the same with the withdrawal. So for I is equal to 0, as long as I is less than 50, I plus plus. And same thing, pass a function there. I know there's a lot of stuff going on, so we can put a couple of spaces there to make this a little bit neater. And okay, let's do the same thing and let's run this. So 0, 0, 0, 0, 0. So no discrepancies. All right, that seems fine. You say like, okay, by 50. Everything's still looking good. Okay, let's add 500 transactions per slice. So now you start seeing discrepancies now. You see that minus 200, then 0 again. So it doesn't always happen, but now you see 500. Before you see minus 200. So you can see some irregularities here and there, and that is not good, especially when it comes to money. So you gotta be very careful about it. So what can we do in order to mitigate this? Well, we can use logs. So what I'm going to do is the following. I'm going to do a mutex dot mutex. Why is the package not auto important? Okay, if not, I'll mutex. That should. Okay, let me see why my package is not being imported. Oh, okay. I forgot one important thing. I'm gonna go all the way to the top. Here, like my wait group, I'm gonna declare my mutex. Very important. Sync.mutex, and then we can go back to the function. Where here is where I'm gonna put my logs. Again, I could also put here the wait group functions, you know, the wait group add and the wait group done. But I think there's a lot of stuff going on for this specific example, and I want you guys to have an example that is pretty clear. Later on, you can add the wait group parameter in the function, and you can pass a wait group and, you know, do whatever you want, and probably clean up a little bit. Actually, I'll do this in this video. But let's go ahead first with this example. So I'm gonna lock this. So what I'm gonna say is lock this specific thread, mutate the variable, and then once everything is done, defer mutex unlock. And essentially, I like this better instead of doing the lock, then the process, and then the unlock, because this is neater. So I actually like the declaration of the mutex lock and then defer mutex unlock. For me, it's just a very neat way of doing things. So now I'm gonna run this. And I'm gonna try to run this 10 times to see if I see some irregularities. I don't see any irregularities so far. Normally, if you increase the number, you tend to see more irregularities. So I'm gonna increase this to 50,000 presses per slice. And that should be very telling. If we would have some irregularities, we would see an error. And it's amazing how quick this is, by the way. Okay, so as you can see, there has been no irregularities, and that is perfect. So that is what we can do, and that is how we can use mutexes. And by the way, if you're liking this video, don't forget to give it a like and subscribe. And just to finish, I'm gonna make a quick modification. Oh, okay. I'm gonna make a quick modification. That way, you know, if you guys are interested in doing your thing and cleaning this up, you can go ahead and do it. So I'm gonna put weight group. This is gonna be a type pointer sync.weight group, and I'm gonna do the same with the deposit. Sync weight group, and then here we're gonna do the same. I'm gonna do weight group dot add 1. Then, well, that is going to be interesting because if we defer, let me see if I can pass two values. Expected but found. Yeah, that is gonna be dicey. Probably if we do this. I'm doing this on the go, so weight group done. So you may have to change the defer. That's the only caveat here. But yeah, same thing. We can put that there, and we can add. This would then now go here, and then we can put weight group done. So now what we have is the following. We can get rid of this. We can get rid of this, get rid of this. Okay, let's see if there's no changes in the example. Let's get rid of that. Let's get rid of that. We can get rid of that too. Now this will be a go routine. And I can pass the weight group 2. And I have to pass it as a reference. Same here. Weight group 2. Expected but found. Why? Oh, yeah. This doesn't go there. Undefined amount. Oh, that is trx.amount, and same here, trx.amount. Okay, so that definitely looks neater. By the way, I haven't ran this in my notes, so let's see how this looks. All right, yeah, so it seems to be working just as good. Yeah, I thought that there shouldn't be a reason why this wouldn't work. The only thing is that then I am not sure if you can do 2 defers or not, so I'm not even going to suggest that. By all means, do use whichever you prefer, whatever looks neater for you. Hopefully this video was informative. You learned about how mutexes work, and yeah. Again, if you like this video and this type of content, don't forget to give it a like, share, subscribe, and I'll see you in the next one.